Hello, everybody. Welcome. And welcome to the State of the Lab for this year. It's good to be back at the lab. So today I want to talk about where we are. It's been my great privilege to be at the lab as lab director for 7 years now. Lately, I've gotten into the habit of taking a half-hour walk or so around the spectacular site you see every day that has a break in the rain. And it's good exercise, but I also get the opportunity to run into people. And I'm seeing a lot of people that I haven't seen for a long time, which is great. It's also great to see the steady progress on cleaning up the legacy sites that's going on all over the site, on rebuilding our infrastructure, and right now on the rapid construction of the new BioEPIC facility. The lab is really in excellent shape, both physically and actually, as you'll hear, we're doing well as we start this new calendar year. And I'd like to give you some detail on why I think that's true. Whenever I give an introductory presentation to visitors about the lab, I start with a slide like this, talking about what the nation needs from us. And it starts out with those scientific solutions addressing national priorities like energy, health, resilience, environment, and the economy, and discovery science. Well, this is really embodied by the 16 Nobel Prizes we have. And after our 2022 Nobel announcements, we have two new ones, Carolyn Bertozzi and John Clauser. They're in the background here in the room with me. We've added them to the Nobel wall. And actually, we're getting ready to name some roads for them. Just like Jennifer Doudna's CRISPR system, Carolyn Bertozzi's bioorthogonal chemistry are great examples of discovery science that turns out to have very big impact on society. And that really captures what we do here. But as I always say about our Nobel wall, there's still room. So we're ready for more. And we are mostly about our people, and I'll talk about that a lot today. Much of our continued research excellence across the lab is due to the distributed research leadership shown here. We are constantly renewing this leadership. And when we do, we make sure that every time we fill one of these positions, we have an ambitious search, develops a diverse candidate pool from around the country. It's interesting, as I talk about this now, that for these 28 research leadership positions, division director, ALDs, and deputies, 10 are now women compared to 4 that were in place 6 years ago. So that's something that has changed on a rather short time scale, pretty dramatically. New members of this group are Stephen Wild as director of the AMCR division, Bill Collins as ALD for Earth and Environmental Sciences, Bill Riley is replacing him as division director. Andrew Scholl is interim director of ALS, and Marianne Piet is our interim ALD of Energy Technologies, and Jessica Granderson is the interim division director replacing her. So all those people are stepped in quickly. I also want to mention our recent ALDs, the associate lab directors, who have gone on to very impressive other influential positions. Kathy Yellick at UC Berkeley, Susan Hubbard at Oak Ridge, Mary Maxson at Schmidt Futures, Ravi Prasher at Bloom Energy are going on to very impactful jobs after this. And that's actually important for the lab as well. So these are our additional lab leaders. This is emphasizing operations and includes the people in the directorate and the operations division directors. And I'll make the point, Jesse Kindra is our new Chief Technology Transfer Officer now, and Edna Annis is in her new interim CFO role. And it was only a year ago that Adam became permanent CIO over the last year. These people have been leading steady improvement in operations performance we have seen over the last few years. And I'm going to talk about that some more later on in the talk. But great science mostly requires great scientists. And so I do make the point, and when I talk externally about the laboratory to the DOE, about our greatest asset is, and the global competition we're engaged in, are these scientists. The new members of American Academy here are Gert Cedar and Alessandra Lanzara and Ramesh Ramamurthy and Pamela Ronald. We have some American Chemical Society awards. Jay Kiesling was named as a DOE Distinguished Scientist Fellow for 2021. That's the highest sort of DOE Office of Science award. We have new members of the National Academy, and Joel Moore and Joe Ornstein, new AAAS fellows this year. And we also have our members of the President's Council on Science Technology, Ines Fung and Saul Perlmutter. And finally, in the last row, some of the earlier career scientists like Brooke Russell and Ben Nachman, who won major awards, camera mathematician Lin Lin, and of course, Ravi Prasher during his last year's ALD won a big award on his heat transfer work. I also just remind us, representing our people of the past, we had it was about a year ago, we had the Bevatron Historic Site Dedication, which is really a wonderful event for us. So, but we're about building the future. That's the thing that we can control. And the future success of our research mission depends mostly on the next generation of research leaders. And that's when we invest time, attention, and support on them. And so we have their early career research program that DOE runs. We had here at the lab in hydrogen physics, Ben Nachman and Matt Pyle from the university won awards there, as well as Marlene Turner for her accelerator work. And then from basic energy sciences, Antoine Wadilla, of course, for his work at ALS on X-ray coherent beamlines, and 2 university awards for Dan Stolper and Michael Zaleto. So we also have given a lot of emphasis, continue every year to give LDRD that's set aside for our early career scientists. Here's the group of 5 terrific scientists who got that this year. And of course, we're just gearing up for the next round right now. And I also point out that at Cyclotron Road, in a different way, we're also developing leaders for the future. These are entrepreneurs, and they will go on outside the laboratory to do other things, but it's still an important part of building the future of science and technology in the country. So I talk about our strategic priorities to shape the future of the lab. And as I have been for a while, talk about our 4 fundamental research capabilities: chemistry and material science, computing sciences, biological environmental science, and discovery science and fundamental physics. But there are also our stewardship priorities. They're attracting, recruiting, and retaining that diverse workforce of the future that's more important than ever. And our infrastructure renewal that is going on all over the site. And I'll talk some more about that. But in addition, we've added an underlying priority that goes across all of our areas, which is accelerating decarbonization. It's a mission priority that really rests on the capabilities that are built up across the laboratory with the Office of Science. So I'd like to talk a little bit more about that idea because it's gotten so much of our attention and the DOE's attention in the last year. We say that we take a science to systems framework for accelerating decarbonization, working from basic science to applied science to technology development to helping deployment. And it's over all the areas of accelerating decarbonization: carbon replacement, removing carbon, and adapting energy systems. It's important all the way across the board. But something that we have uniquely at the lab is that our research teams, we start, of course, with basic and applied research, but we also have systems engineering, techno-economic analysis, and life cycle analysis, people worrying about deployment and scale up. We have strength in AI and computational science, a deep industry engagement in all these sectors. And finally, we worry about energy justice and the mineral supply chain because those are national concerns. We can move rapidly on these technology campaigns because of the core capabilities the Office of Science has built up here. But now, and especially now, as we have these Earth shots, and we're now looking at Earth shots having new research centers and new call coming out for what are called EERCs for the Earth shots. We are applying this technique to every one of these, and we feel that we are ideally positioned to have impact in this area. So let me talk a little bit about research accomplishments, and of course I could do 3 hours of this, but I won't. I'll take a few examples, and I want to start with the fact that computing sciences successfully completed 2 giant upgrades in the last year. These are ambitious, difficult upgrades, ESNet 6 is a new research network with completely new architecture and technologies. They completed the project on time and under budget while operating the ESNet, while keeping everybody alive and going, which is amazing. And we had a great unveiling event here back on October 11th. And Perlmutter, that you see our Director of Office of Science signing the Perlmutter system. It's the new NERSC 9 system, representing a major step forward for all of the Office of Science research that depends on simulation, analysis, and AI. This just the phase 1 system was number 5 in the top 500 list. But we're more important than being on that list is the fact that this has been, the whole system's been integrated into NERSC, and users are taking full advantage of it every day. Now let's switch to another completely different area of the lab. An example of our world-class environmental research is the study of the impact of storms on the Amazon forest that by the NGE Tropics team. You may have just seen a note, a press piece about this. We hear a lot, of course, about the impact of deforestation in the Amazon on the carbon dioxide balance and climate change. This is the impact in the other direction. Climate change also has a profound effect on the Amazon forest. And these people are actually making that known so that we at least realize what we're doing. Another completely different area of the laboratory, of course, is physics and fundamental physics. So I'm taking one example. This is the remarkable dark energy spectroscopic instrument as a highlight. Remember, a year ago, the DAISY project, or so, 2 years ago now, that won the Project Management Excellence Award in 2020 for delivering this amazing instrument on time and on budget. Well, in May 2021, they started the primary survey to collect spectra from 40 million galaxies and quasars. They'll make a 3D map of the universe out to 12 billion light years, most of the life of the universe. And here, that in that circle is a quasar that is 11 billion light years away. And look at this level. This is a spectrum of light that comes with it, how detailed that is. And that allows them to measure the redshift, and from that a distance, which gives us that 3 dimensions. So the Mayall telescope and DAISY instrument went through quite a year. There was a Contreras fire that ravaged Kitt Peak. And 3 months later, they were back on taking spectra, and they're still ahead of schedule. So this is a remarkable accomplishment, and great science will come out of that for many years. So one of the coolest discoveries that we had last year was this giant bacteria in the mangrove swamps of Guadeloupe. Bacteria is so large it is visible without a microscope. That's either very cool or somewhat creepy, depending on how you see it. The JGI team analyzing the bacterial cells has used the full set of tools available here, from single-cell genomics to transmission electron microscopy to hard X-ray tomography. It really shows what a laboratory can do when attached to this natural discovery. And everything about it challenges our concepts of what a bacterium is. We also have one of the strongest teams of material scientists in the world, have for years, forever. And this year, a group of them found the toughest material observed so far. It's a chromium cobalt nickel alloy. And the fracture toughness of the alloy at 20 degrees Kelvin makes it potentially useful for a range of cryogenic applications where that hardness is important. Really very nice work in science. And finally, just before December 23rd, this edition of Science contained an article by Drew Lilly and, yes, Ravi Prasher at VTA, announcing a new method of refrigeration, amazingly, ionocaloric refrigeration, which is very high efficiency with environmentally friendly refrigerants, which of course has been very hard to achieve. So there's a really interesting perspective article in Science that talks about the great promise of this technology. I was reading that yesterday. It's very cool. So those are some highlights, but well, I can't go too long without talking about money. So this chart shows the trends for total funding to the lab over the last 5 years. Overall, our new funding for FY22, the year that ended several months ago, was 1.445 billion, which is about 30% more than the previous year. Well, that's a record for us, of course. It did include 196 million from the Inflation Reduction Act. So that added that extra bump, which provided advanced funding for several of our important construction projects: ALS upgrade, the NERSC upgrade, some top-off funding for BioEPIC and more. The research budget itself has gone up pretty steadily at about 5% per year for the last 4 years. The line item construction and capital equipment funds, which builds that capacity for the future, has been increasing much faster than that. I will say, because people do ask me about, the lab headcount has increased by about 12% over the last 5 years. So that's like 2 to 3% per year. So it's been steadily growing, but slowly. And we're starting to get reliable estimates of our FY23 funding that have come out of the bill that was passed just before the end of the year. And total funding is estimated to be about 1.4 billion, almost as much as last year. And it still has a lot of line item construction in it. So the fact is, the federal government is supporting the lab very well. So this is a busy slide, but I want to make a point. This shows the number of critical projects building the future of the laboratory. That status in 2017, that's a list I showed to our advisory board 5 years ago. And it has these projects: ALS Upgrade, DAISY, Lex Zeppelin, LZ, Nurse 9, Greta, Exascale, ESNet 6 science projects. And all those were just getting going at that time. And frankly, I said, we really have a lot at stake here. This is building the future, but these are a lot of big, ambitious projects, and we need to get all of them right. And this is going to take a real effort to do it. And then on the right are cleanup and building projects. Well, that was the status in 2017, and it made me a little nervous at the time. And I added a column which had our status when I talked to them in September. And well, ALSU is now in full execution mode now. That's, of course, our largest and longest project. But DAISY had its first slide in 2019, had a wonderful performance that you're seeing. The LZ experiment it sealed up in 2021, and it's got its first results out. Nurse 9, which was just getting going, it's now finished, and it's actually taking over from Corey as the workhorse system. Our Greta experiment for nuclear physics is in construction, but it's going to be finished in about a year or so. The Exascale project we're wrapping up, and the ESNet 6 I already talked about. All of these projects, and that's $500 million worth of work, has been completed on time, on budget, and is doing great research. And it's really a strong accomplishment. And then we also executed the Old Town demolition work, built a large new laboratory facility, IGB, and got going on BioEPIC, which was approved at $165 million for occupancy. So this is really a remarkable level of achievement, and people all across the lab should feel proud about this. So let's step back a bit and look and see, because this is the era of building the Berkeley Lab of the future. And you can see we have executed $100 million of demolition and cleanup work at Old Town, and about the same amount at Bayview. IGB is done, and it's a central point of our laboratory now. And we're well along in BioEPIC, as all of you have been seeing that going on. We've been given approval for our revised plan for demolishing the old cafeteria and replacing with a brand new cafeteria and conference room complex, something the lab has needed for years, well, probably decades. And this represents a very big vote of confidence in the future of the lab. We've built our longer range planning on, we have in our longer range planning that AMDV, that's Advanced Materials Discovery Building, is the first new building at Charter Hill, and others will look to follow, and BioGem on the Bayview campus. And we're also embarking on a large effort to rebuild the B71 complex, one of our oldest big facilities, to make it better suited to the exciting accelerator developments at Bella Center. This is really an era of transforming the laboratory for the next 10 and 20 years. So let me talk about a few of these examples. BioEPIC, that building is going up, so you might be asking, what's it going to do? Well, Berkeley Lab researchers are developing the new capabilities needed to advance our understanding of plant, microbe, and soil interactions as we get ready for the BioEPIC facility. We started a few years ago with LDRD initiatives, and now it's been picked up by BER is funding these projects. And they're looking at ways of building fabricated ecosystems at various scales, which will be used with new computational capabilities to model the research that's going out in the field, so that one can actually develop predictive models of this. It's been thrilling to see the BioEPIC building rising so quickly over the last year. And people are working hard to get these programs with these new facilities ready to go onto the first floor of that. And we're also actually going to have some other equipment on that first floor, like our cryo-electron microscopy work. We're starting to looking to start moving into that in October 2024, and really, again, a building that will transform our site. So now that, turning to Charter Hill, which is the space next to the Advanced Light Source, where some of our oldest World War II era buildings were, that 100 million plus demolition and cleanup projects are pretty much complete now. We're developing a plan for a campus dedicated to advancing materials and chemistry research from basic to applied. And we're in discussion with the OE, both programs and science laboratory infrastructure program, about the advanced materials discovery building to get it in the queue, basically as our present projects roll off. And we're working with environmental management on completing, this is the Bayview construction. You can see this shows IGB and BioEPIC as a built building. And of course, the next one there, which is even bigger, is BioGem. That would bring our focus on biomanufacturing and other parts of the bioeconomy, bringing that work from, that's now in Emeryville. This would be the third large laboratory and office building on the site. And when you look at these buildings, I remind you that up until a few years ago, SLI had not built buildings at laboratories more than $100 million. So the level of investment they have been, and we hope that will continue to make on us, is really quite remarkable. Well, we've been building not only facilities, but we've been building institutions, because the most important part of our stewardship is the stewardship of our people. So this is just a timeline that shows some of the changes we've made over the last 5-6 years. Starting in 2017, we hired John German and built up his remarkable, strong strategic communications team, including internal communications across the laboratory. We hired Lady Edos also in 2018 as the Chief Diversity, Equity, and Inclusion Officer, and began building the IDEA program that is still running strong. We hired Faith Dukes in February 2019 to build the K-12 education program that is doing well and growing, and established the Career Pathways Office that year with Meg Rodriguez is now leading. In 2020, we started to have lab-wide stewardship conversations. We added equity advisors to our hiring teams. And now with the Didi Chakravarti in the lead, we rolled out the Stewardship Values and Stewardship Summit in 2021 and a Stewardship Town Hall soon after. And I'll just add, of course, we have our new website launched in September. So all these things are developing how to communicate the culture that we want at the laboratory, how we value our people, and how we build the institutions that support that. So this big table of numbers has to do with our grades. This lab I get a set of grades every year. You can see them on the DOE website, they're public. And so this is what we and the other 9 Office of Science labs got this year. And just to say, some background, there are 8 goals. The first 3 cover parts of research. The 4th covers leadership and stewardship. And then the next 4 are about operations and business systems and facilities. So this year, as you see in white, we received A in the quality and productivity of our R&D. That's why we're here. That's our primary mission. A- in all the other 7 goals. We were the only SC lab to do so last year. This is a difficult grading system. Every A- is hard earned. No lab has earned this high a GPA since 2009, and we've now done it twice, 2 years in a row. So the reason I'm going through this is to say This is due to all of you. Everybody at this laboratory has contributed to these. And I just talked about how much the DOE is investing us. That is, to be honest, as I see it, this is our reward for, of course, we have wonderful programs, but we're being rewarded for the fact that we're taking such good care of the dollars invested here. And the DOE is willing to invest so much in new facilities and infrastructure because of our world-class research, because we've earned their trust for managing and operating this lab as a national asset. All of us working together earned these grades. I'll just say one more thing about this to give focus a little more attention. We earned such stellar scores because of the sustained attention to improving operations across laboratories. That little oval there operates that both last year and this year. The reason we got it was we got A minuses in all 4 of the operations areas: environment, safety, and health, business systems, facilities, and security and emergency management. Just a few years ago, all those grades were B+, which meets expectations. And this has been a major effort by by a good part of the entire laboratory, with steady improvement, pushing it up to this point. And believe me, the people in the Office of Science really have seen this, and we're seen as now really a standard among the labs in these areas. So congratulations. We took the chance to celebrate some of this at our Directors Labs Awards this year. Some of the teams and individuals who made exceptional contributions to the life of the lab. Security and Emergency Services, number one, they of course had a protective services leadership team, developed best-in-class emergency management system, and we've had quite a few emergencies over that time. Human Resources, Service Award to Wade Crossan, and for the International Research and Scholars Office. The 2022 IDEA Award went to Miles Green for all he does to elevate the culture of the laboratory. John Corlett for his remarkable work on strengthening the project management office. Laurel Davis won the Safety Award for exceptional efforts during the last few years of the pandemic. And the facilities team won an award for successful management, of course, of COVID-19 and power outages and wildfire risks. And Mark Scott won an operations award. Finally, the CFO office won for its seamless transition of the payroll system. So I want to give some credit to these people, hardworking people who have really stepped up beyond meeting expectations to do really exceptional things. So to wind up this part, I just want to go back to that wonderful photo of our spectacular site. Although we have had many people working at the lab for some time now, the level of activity is really picking up even more now, which is great. We have shown that many people can work in a hybrid mode productively. At the same time, our team science is critical to the impact we have on science, technology, and society. So all of us now are coming to the lab intentionally thinking about what do we need to be at the lab for? We need to be there to practice team science, to promote collaboration, to provide the informal mentorship that our teams are always doing, and that collective creativity that can be sparked when people come together. So every division director talks to me about the magic of having people back meeting in person again, sharing ideas with people in a way that for all the things we can do on Zoom, there's something special that comes from those in-person meetings. For me, it's just great to meet so many people again at the lab, especially those who have joined our community in the last few years. Every time a group meets, I have a large group meets, I say, raise your hand if you have joined the lab since March of 2020, and it's usually 30% of the people in the room. It is the diverse groups of highly trained, creative individuals committed to working together in teams on these grand national challenges that makes us what we are, and together we can accomplish great things for society. So with that, I'd like to close this part of it, and we'll actually now just have some conversation. So thank you.
Mike, thank you, and good morning, everyone. This is John German with Strategic Communications, and joining us, we have Michael Brandt, the Chief Operations Officer and Deputy Lab Director for Operations, and Carol Burns, the Chief Research Officer and the Deputy Lab Deputy Lab Director for Research. Thank you for joining us. We do have some questions that we'd like to ask you, our senior leaders. And that first question is, what is your sense of the expected funding environment for the lab in the near future and over the longer term?
Yeah, well, as you saw, the last year and this year have been really remarkable in funding. I'll say, first of all, our capabilities couldn't be matched better to what the nation's trying to do right now for clean energy technologies, as well as fundamental science and technology. We are addressing the biggest, highest priority problems the nation is facing. And policymakers and sponsors tell us this. When we were at the White House in December, we had the upper level people at the White House saying how well matched these labs were to what they were trying to do. So the Office of Science, which is our parent organization, funds 73% of the lab. Its budget is up about 8% over for the year we're now in. And we're going to see when the next President's budget request comes out, if that continues. The other program office budgets are up as well, mostly keeping up with inflation, even when inflation is high. So our highest priority projects generally have what they need to keep making progress, especially those construction projects, which were pre-funded by the infrastructure bill. Now, we know federal budgets go up and down. I've been in I've been a lab director for 14 years. This has been the best period I've gone through for actually having increased budget year on year. So we don't have any particular intelligence regarding future budgets. We could be hitting a down point a few years in. But the important thing is that we're positioned pretty well. As you see, a lot of the extra funding has been going into these projects that build for the future. Our personnel count's only been very slowly growing, and I think we're well positioned to wherever the budget goes. I think we're in a good position.
Thank you, Mike. This is Diane Wentworth, also with Strategic Communications. Mike, I have a question for you. How is the lab being, or is it being affected by the recruiting and retention challenges that other national labs are having?
Yeah, that's a really important point, because it's the thing that in some sense the lab directors are talking most about now. And when I talk to division directors and LDs, they talk to me about their issues, how there are fewer people when they're recruiting now, and keeping people here is harder. This is larger, of course, than just this lab or the labs. This is a national and international issue. Every organization is facing those challenges right now. So people are moving around more than usual. And actually, we have in many areas a shortage of workers, of talented people to do these jobs. So our only response to this primarily is to make sure that we're the lab that remains a great place to work, and people want to come here to work. That's really our main asset. We have to continue to create an environment where everybody knows they're valued and respected, that they're listened to. Modernizing our facilities, we talked about that. That's about our people too, because people want to do research at a place that has world-class facilities. People also want to work side by side with people who are world experts. And the fact that we have such a strong team here is what brings more people here to work with them. So in the end, the stewardship of our people at our facilities are also exactly what we should be doing to make sure that we can compete in this competitive environment for talent that we're now in. And I think it's a challenge. It's a new challenge. Everybody has to take it seriously. But that's what it takes, is what we are trying to do anyway.
Thanks, Mike. I have a question for Carol. Carol, what aspects of our current research environment are you most worried about?
Thanks, John. So I have to say, one of the things I am spending the most time thinking about right now is enhancing collaboration and innovation. Mike showed us a lot of really excellent science that the laboratory is producing, and I want to make sure that we're in a position to continue to do that. I'm very impressed with the stewardship values of this laboratory, and a number of them, like team science, innovation, and trust, really rely on relationships. I've had a series of small group discussions over the last year or so with employees And one of the things that people repeatedly bring up are their concern about how are we going to build those relationships, particularly with our early career researchers or others who are similarly new to the laboratory. How do we help introduce them to the team science and the culture of Berkeley Laboratory? We're talking about ways to try and incentivize bringing people back together. Certainly, I know people value the flexibility of our hybrid environment, and there's many advantages to that, but there's no substitute in some regard for some of the engagement that we all want to have. So we're looking for tools to do that. I think summer's going to bring a time when we particularly want to pay attention to that. This is usually about the time of year I start thinking about, goodness, are we going to have students on site? Are we going to have visitors? Are we going to have science meetings? And I think we owe all of those individuals the experience of coming to Berkeley Lab as well. So I'm looking for ways to try and bring people together on site to engage and collaborate. That kind of work is what's gotten this laboratory to the good position where it is today. And I think we'll be looking for everyone to come up with good ideas to figure out how to bring us together. Quite frankly, I just think it's time.
Thank you, Carol. I have a question for Michael. Michael, we need food and coffee, right? To do all this great work. What are the food and coffee options at the lab in the next couple of years as we have all of the construction going on?
Right. First of all, good morning, everyone, and thanks, Diane. As Mike said, the good news is the Department of Energy continues to invest in our laboratory. And with that comes some challenges. And one of those is closing the cafeteria and losing convenient access to food and beverage service, such as coffee. And it's difficult for all of us. So I've been working with my operations leaders to find new locations for us to be able to provide coffee and food on site. We currently have a food truck in the parking lot outside of the Integrative Genomics building. And we're planning to bring another food truck on site as soon as the demand increases for that. We also installed a coffee vending machine on the third floor of the IGB. And next month, we'll begin offering food service options at the guest house. And these include grab-and-go sandwiches, salads, drinks, microwavable meals, and snacks. We're also planning to have either a coffee truck or a coffee cart available on site beginning in late February. And as always, food delivery services such as DoorDash, Uber Eats, pizza delivery, and other food delivery options are available and permissible to have those delivered to your building. And then over time, we'll continue to listen to you and add additional food and beverage services as we're able to do based on demand. Okay.
Could I add a little bit to that?
Sure. Thank you.
Certainly, I recognize that a lot of the challenges that we're facing have a lot to do with the construction that's going to be on site. And I want to say something about the need for our infrastructure revitalization program. Mike certainly emphasized that the strength of our laboratory is the people. And we want to put ourselves in a good position to have good people now and good people 10 years from now. At the same time, it's really evident that part of what brings people to any laboratory is going to be the strength of the scientific infrastructure. We know that this is a challenge at our site. I don't think I've found anybody who doesn't think that infrastructure needs attention right now. And I will say that it's difficult to build on a site such as ours that's an urban campus, a dense campus on a hill. But I think we are at a unique juncture right now. We are performing well. The department trusts us. The department trusts the execution that Michael and his folks have demonstrated. They are investing resources, and we have plans for what to do. So I'm actually really excited about embarking upon some of this infrastructure revitalization. It's going to be challenging. We're birthing the new laboratory, and the labor pains include different ways that we're going to have to utilize some of our space and some of these disruptions we're going to have to deal with. But I think the only way to do it right now is really to move forward and get through the hard part to have a bright lab for the future.
So first of all, thanks for that, Carol. I also want to mention that we have seating areas outside with umbrellas and tables over by the IGB where we have the food trucks outside of this building. And if you do need some umbrellas or picnic tables in your area, please let us know. We'll make sure we can provide those, because the discussions over coffee and lunch are important to all of us as part of collaboration. Thanks, Diane.
Thank you both. Let's see, everyone's favorite topic. Everyone wants to know about parking, and what with all the construction occurring over the next few years and more people coming on site, what is the lab doing to manage parking for employees?
So first of all, I want to thank John Ternowski for working with all of you and listening. We have conducted lab surveys, and we also have a working group examining the equitable use of parking around the laboratory. And John has done an inventory of the laboratory. He's done that periodically. And currently we have about 250 to 300 unused parking spaces available at the lab. I also know that spaces aren't always found in locations that are convenient. But John also has another solution for us, and that if you're parked some distance away from your office, we have a shuttle service only on the site, and it runs every 10 minutes, and it's convenient. And I would recommend that you investigate using the shuttle to move from your car to your office. Another possible solution to the parking challenges that we have on site is to select different commuting options. We have some new transportation options coming to the lab, including sit-down scooters, electric bike leases that each of us as individuals can enter into, and we have a new rideshare partnering program. And of course, we also have the lab shuttle that moves around different neighborhoods in Berkeley, and you're eligible to ride the bus from home to the laboratory. And I also want to point out that we're trying to manage our parking spaces. So because we're seeing an increase in the number of people returning to our main laboratory site, and that's good news, we will be reinstituting regular hours parking, the parking permit requirements in the next few weeks, and more to follow. And on that specifically about when it's going to be implemented, and we'll make sure that that information is available in Elements and other sources. Okay, thank you.
Thank you, Michael. Mike, I have one last question that we normally don't throw into these sort of sessions, but how is your health?
Yeah, thanks for asking, Diane. And I should say, when I walk around and meet people, that's mostly what they ask me. And what I say is I'm feeling great. I had my last radiation treatment on December 8th, and 3 days later was flying to Washington for our meetings there. And I'm walking several miles a day around the hills. I'm probably in better shape than when I used to run along the beach in Santa Barbara every day back when I was there. And the early tests are very positive. So my family and I are now feeling very optimistic about where things are. And I've been very lucky. And I appreciate everybody's support through this time.
Great news, Mike. So that concludes our session. I want to thank Mike, Carol, and Michael for taking the time to share some of the lab's accomplishments and plans with us. And thanks to everybody on Zoom for joining us today. Have a nice day.
See you at the lab, everybody.
Bye-bye.